For eons, our species has walked this earth, gazing up at the heavens, bathed in the generous light of distant stars, and pondered our place in the grand design of the cosmos. We are a species driven by curiosity, possessed from our first tentative steps by an innate drive to understand, to explore, and to master the intricate forces that shape our reality. It has been a journey undertaken across countless generations, from the first attempts to chart the changing seasons on cave walls, to the ancient astronomers who peered into the night sky, mapping constellations and dreaming of reaching those very stars. Every civilization, every culture has contributed its own unique thread to our ever-expanding tapestry of knowledge. We learned to observe, to question, and most importantly, we learned to learn. The path was seldom straight. It meandered through ages of enlightenment and epochs of shadow, punctuated by the dazzling insights of minds that dared to see beyond the horizon of their time. Think of the revolution sparked by Newton, revealing the universal laws that govern the graceful dance of planets and the humble fall of an apple. Consider Einstein, forever altering our perception of space, time, and gravity with theories of such profound elegance they continue to resonate through the halls of science. Journey with us into the strange and wondrous realm of quantum mechanics, where the very fabric of reality behaves in ways that defy our everyday intuition, yet unlocks power and possibilities previously unimaginable. Each discovery, a stepping stone, each equation, a new lens through which to view the universe. We have mapped the unfathomable distances of the cosmos, peered into the hearts of dying stars, and traced the delicate web of life that connects every living thing on our own precious world. We came to understand our planet not as an infinite resource, but as a fragile, interconnected ecosystem, a delicate jewel suspended in the vastness of space. And at the heart of our planetary system, our constant companion, our life-giver, the sun, a colossal nuclear furnace 93 million miles away, fusing hydrogen into helium, releasing energy on a scale that dwarfs any human endeavor. For millennia, we revered it, deified it, studied its cycles, and bathed in its life-sustaining radiance. Its energy, a daily gift, has shaped our world, driven our climate, and fueled all life. The sheer, almost infinite potential held within the 5 billion years of sunshine the Earth still has left, a profound timescale, a monumental resource, prompting the critical question, how will we choose to use it? For generations, scientists, thinkers, and innovators have dreamed of truly harnessing this stellar largesse, of finding a way to tap directly into this boundless cosmic energy source. The research has been painstaking, the challenge is immense, but now, after centuries of relentless inquiry, of standing on the shoulders of giants, of piecing together the immense puzzle of the universe, we find ourselves at a precipice, a moment of profound significance. We have gathered the knowledge, we have studied the scientific results from around the globe, we have understood the galaxy, and at long last, we truly understand how we can use the sun's endless and expansive energy to power our world for free. It sounds like the stuff of myth, doesn't it? Free energy from the sky, the kind of promise whispered by charlatans and dreamers throughout history. And yet here we are. The journey from understanding the fundamental physics of a star to capturing its light in a meaningful way has been a marathon of human ingenuity. And the truly remarkable thing, after all that cosmic contemplation, those millennia of staring up in baffled awe, that deep dive into the quantum universe, it turns out that the practical application, while breathtakingly clever, has an almost disarming elegance to it. We've essentially figured out how to build a very sophisticated leaf, a man-made marvel that does what nature has been doing for billions of years. Only, we're asking it not just to grow, but to power our entire civilization. It's almost deceptively simple. One might even say, now that we've cracked it, well, of course. Why didn't we think of that sooner? Quite neat, really, when you finally get the hang of it. This is the age of ingenuity made manifest, where theories leap from blackboards and become tangible, transformative realities. Yet, the path to widespread adoption of solar energy, particularly on the grand scales needed to truly shift our global energy paradigm, has been fraught with its own set of earthly challenges. Conventional solar farm construction, for all its noble intent, often involved complex logistics, extensive fieldwork, significant ground disturbance, and lengthy deployment times. An intensive, high-risk field environment, with crews battling weather, terrain, and the intricate assembly of countless components under the open sky. The very process sometimes felt like a bottleneck, slowing the urgent race towards a decarbonized future. But what if the entire approach could be re-engineered from the ground up? What if the solar supply chain itself could be reinvented? What if we could move from that intensive, high-risk field environment to a quality-controlled, lower-risk factory setting, and then deploy these marvels of energy capture with unprecedented speed and simplicity? This is not just a hypothetical question. It is the reality being forged by a company named 5B and their flagship technology, the Maverick. Consider, for instance, the United Kingdom, a land renowned for its dramatic history, its rolling green hills, its rather unpredictable weather. Perhaps not the first place that springs to mind when one thinks of pioneering solar technology on a grand scale. Yet, even here, beneath skies that offer more than their fair share of cloud, the seeds of a sun-powered future, facilitated by radical new thinking, are taking firm root, and what we find here is no ordinary solar installation. Forget for a moment the familiar panels adorning rooftops, or even the sprawling fields of traditionally mounted arrays that take months to construct. This is something else entirely. This is a revolution in deployment, in efficiency, in thinking. This is the 5B Maverick, an ingenious solution, proudly Australian-made, designed to simplify and accelerate solar farm construction on a scale previously unimaginable. Picture this: a prefabricated, pre-wired ground mount array, typically delivering 48 to 50 kilowatts of power, that deploys not in weeks or months, but at astonishing speed. It's a complete step change from the way conventional solar technologies are designed, assembled, procured, and constructed. The core philosophy: shift complexity from the field to the factory. Imagine a facility where module assembly, all the intricate cabling, the critical connections, and even the initial testing are performed in a controlled environment. This isn't just an adjustment, it's a fundamental re-engineering. The result is a pre-assembled solution that dramatically reduces the number of tasks, and critically, the time spent on-site. The Maverick arrives on location not as a disparate collection of parts, but as a consolidated unit, ready for action. 4 of these substantial 50 to 70 kilowatt Mavericks can be efficiently packed into a single 40-foot shipping container, or onto a flatbed truck, streamlining logistics to even the most remote corners of the globe. And once there, the magic truly begins. With a small crew and a telehandler, these arrays are rolled out, unfolded, concertina style, with minimal ground penetration, often no deeper than what's needed for a simple ballast. Forget extensive cable trenching, this is about a shallow footprint, both literally and environmentally. The integration is plug and play, a testament to its sophisticated pre-engineering. It's a solar solution tailored to overcome the unique challenges that remote operators, be they in mining or community power, often face. The benefits cascade outwards, touching every aspect of a solar project. For EPCs, solar farm developers, owners, and operators, the Maverick offers a compelling new equation. We're talking more power per hectare. Its energy-dense design, typically achieving 98% more energy yield per unit area than single-axis tracker systems and 87% more than fixed tilt, means optimizing land usage, a critical factor where space is a premium, or on sites with challenging topography. At around 0.7 hectares per megawatt peak, it makes previously unviable sites, landlocked or constrained, suddenly open for development. Consider the economic impact: significantly lower capital expenditure. Savings on land are just the beginning. Less cabling, no deep trenching, reduced accommodation and messing costs for smaller, faster-working crews, and simplified logistics all contribute. The risk profile of a project also shifts dramatically. Geotechnical risk is reduced due to minimal ground penetration. Weather-related delays, the bane of many construction projects, are mitigated because the on-site deployment is so rapid. We're talking about the capability to deploy over a megawatt peak in a single day with a team of just 10 people. That's up to 10 times faster than conventional solar technologies, with an up to 80% reduction in key on-site activities like geotechnical, mechanical, and electrical engineering. And what about waste? In a world increasingly conscious of its environmental footprint, the Maverick shines. On-site waste can be limited to the size of a carry-on bag. The factory assembly allows for more controlled, efficient waste processing. And when the project life concludes, easier site remediation is another vital plus. This isn't just about a single product, it's about an ecosystem. 5B's primary production facility in Adelaide, South Australia, is complemented by a versatile global assembly model. This drives cost efficiencies, increases capacity, offers delivery flexibility, reduces time to market, allows for project fungibility, and shortens assembly lead times. And the innovation doesn't stop. Their advanced manufacturing pilot line, currently under construction, represents another quantum leap, not just for 5B, but for the entire solar industry. The goal? To produce a complete 5B Maverick array, a 50 to 70 kilowatt solar power unit every 30 minutes. This high-volume advanced manufacturing will substantially reduce the total Maverick cost, making gigawatt-scale solar farms, which once seemed impossibly vast and time-consuming, entirely feasible. The Maverick is designed for resilience. It's built to perform in extreme environments for a design life of 25 to 30 years. It can withstand high wind loads, up to 72 meters per second, meeting ACE 1170.2 standards, and is suited for highly corrosive conditions with C4 corrosion resistance. It can even handle flooding with a standoff height of up to 650 millimeters. This robustness makes it ideal for remote, off-grid mining solutions, where it has been deployed on waste rock dumps, repurposing otherwise idle land for productive solar generation. At the Jundee operations in Western Australia, this very technology allowed Northern Star Resources to use their existing waste rock dump, opening up a traditionally underutilized land resource for clean power. For the Liontown Resources Kathleen Valley Lithium Mine, also in WA, where the remote site meant constrained labor, 17 megawatts of Maverick arrays were deployed by a team of just 10 in only 50 days, a testament to the 70% reduction in labor hours compared to single-axis trackers. It's been deployed in cyclonic regions like the Tiwi Islands, surviving powerful storms, and on reclaimed landfill sites, like the Albury Waste Management Center, where its minimal ground penetration was key to preserving the landfill's membrane. The system's ability to relocate with ease is another game-changer. For projects with uncertain long-term operations like some mining sites or temporary facilities, the Maverick can be packed up and moved as easily as it was deployed. This dramatically reduces the risk of stranded assets and ensures cost-effective decommissioning. At the Nova Nickel mine in WA, the Maverick was chosen precisely because the solar solution needed to be removed after just 5 years. Its maneuverability completely eliminated the risk of stranded assets. This flexibility extends asset life, allowing the full value of the solar system to be utilized, perhaps even across multiple sites over its lifespan. It means that for projects requiring access to underlying infrastructure, like the gas line beneath the Colon power plant in Panama, arrays can be quickly removed and redeployed. The technical ingenuity extends to its orientation and integration. While typically deployed with panels facing east-west for optimal all-day generation, the Maverick's unique low-tilt angle of 10 degrees allows for almost any orientation with only minor reductions in energy yield, usually less than 1%. This gives incredible flexibility in site layout, accommodating unusual site aspect ratios or exclusion zones. And yes, you can even string east and west-facing module strings to the same inverter MPPT, as the maximum power point voltage of these strings will be virtually the same, simplifying the electrical balance of system. It's inverter agnostic, having been successfully installed with a wide array of major brands. And here, in this specific UK project, one of only 2 such 5B Maverick systems in the country, this technology isn't just an abstract marvel, it's a working reality. A quiet titan diligently soaking up every available photon. But its purpose here extends beyond simply feeding electricity into the grid.
So what have we got in here then, Tom?
So we've got 2 electrolyzer stacks, so a proton exchange membrane, 15 kilowatts each.
Okay.
So you can see a sandwich type structure around here. So what we're doing is we're investigating the most efficient way to produce hydrogen directly from the solar array, using directly DC power from the solar array without using any traditional power electronics. So the idea is we have 2 stacks, one using conventional high-frequency based power electronics. The second one is using our proprietary direct DC to DC system.
Okay. Amazing.
It is part of an even more ambitious endeavor, linked to the very future of clean fuel, for if capturing the sun's energy is the first step, and deploying the means to do so with such revolutionary speed and efficiency is the second, the next great challenge is storing it, making it available when the sun doesn't shine, or when the wind doesn't blow. This is where we venture into the realm of green hydrogen, a fuel of immense promise, created by using renewable energy to split water into its constituent parts, hydrogen and oxygen. Clean, versatile, and with the potential to decarbonize industries that electricity alone cannot easily reach. And this particular 5B Maverick array is a crucial component in a visionary project driven by a company called HyWaves. Their mission is bold and clear: to envision a world where green hydrogen is produced locally, efficiently, bringing us one significant step closer to decarbonizing our world. HyWaves focuses on the crucial interface between renewable energy generation and hydrogen production. They've looked at the traditional, often cumbersome process and asked, can we make this simpler, smarter, more direct? Their answer is a resounding yes, a technology that simplifies the electronics design architecture, enhancing electrolyzers to significantly increase green hydrogen production, 7% more efficiently, and 19% cheaper than current methods. The HyWaves solution maximizes the electrolyzer's output, even from the fluctuating input of renewables, ensuring that the clean energy harvested by the Maverick is converted into clean fuel with optimal efficacy. This technology, demonstrated at Cranfield University and scaling up, perfectly complements the rapid, efficient power generation of the Maverick. Such ambitious undertakings, of course, are not born of algorithms or circuit diagrams alone. They are forged in the crucible of human intellect, passion, and an almost stubborn perseverance. They are driven by individuals like Thomas Delaney, whom we, Matt and Cass, had the distinct pleasure of meeting. A chartered engineer, a doctor of philosophy, steeped in aerospace and renewables, embodying that blend of sea-level vision and deep technical expertise. It's this spirit, multiplied across teams like those at 5B and HyWaves, that propels us. Think of the people whose skills find new purpose. Chris, who once built fast cars at the Holden factory in Adelaide, now finds himself building solar farms at speed, keeping manufacturing alive, his expertise seamlessly transferred to this new green frontier. I've gone from building fast cars to building solar farms at speed, he says. It's keeping manufacturing alive here. Or Buatras Ritrakul, a principal systems engineer at 5B, with 2 decades of experience spanning underground railways in Thailand to automating thin-film solar cell production in Silicon Valley. Now she's incorporating robots to accelerate 5B's production, working on the advanced manufacturing project that will ramp up production to gigawatt scale. No one has done this before, she notes, highlighting the project's global significance. And Sarah Pope, a senior solution delivery manager at 5B, who journeyed from a receptionist to overseeing project delivery for multiple solar farms, witnessing firsthand the growing variety of roles for women in renewables. I wanted to work for a company that put a woman in charge of its biggest, most exciting project, she recalls, inspired by seeing a female project manager for 5B. These are the human faces of this revolution, the skilled hands and brilliant minds making it happen. And for these technological marvels, these silent workhorses of the green revolution, to perform their vital task flawlessly, they require care. They need to be kept in peak condition, every surface optimized to greet the sun's rays, every connection sound. That's where a small part in this grand narrative comes in. Myself, Matt, and my partner Cass, ensuring that this particular 5B Maverick array, a jewel of sustainable technology, is pristine, operating at its utmost efficiency, ready to play its crucial role in producing clean energy and, ultimately, green hydrogen. A simple task, perhaps, in the grand scheme of things, but a vital one for these cathedrals of modern science. So, let us take a step back and marvel. Humanity, in its relentless quest for understanding, has reached a point where we can take the very light from our nearest star, filter it through layers of ingenious technology that is prefabricated, rapidly deployed, robust, efficient, and even relocatable, and use it not only to power our homes and industries, but to create a clean, sustainable fuel that promises to transform our future. We are, in essence, performing a kind of benign alchemy, turning sunlight and water into hope, with tools that are themselves masterpieces of practical design. And isn't there a delightful irony, a touch of cosmic humor in it all? After millennia of complex philosophies, of intricate scientific theories, of wrestling with the very nature of existence, one of the most profound solutions to our planet's challenges involves, well, catching sunlight very, very effectively with systems that roll out like carpets and unfold like metallic origami. Of course, the journey to this effective catching has been anything but trivial. It represents the pinnacle of our current understanding, the culmination of countless hours of research, design, and sheer hard work by people like Thomas, the visionary teams at 5B with their Maverick, and HyWaves with their hydrogen innovations. It's a journey that has seen awards like Iberdrola's Startup Challenge and recognition as a World Future Awards winner for Best Solar Solution, underscoring the global impact of this approach. But the result is something of breathtaking elegance, a synergy between nature's boundless generosity and human ingenuity. This 5B Maverick array, coupled with the groundbreaking work of HyWaves here in the UK, is more than just a collection of solar panels and advanced electronics. It is a beacon, a tangible demonstration of a future powered by clean energy, a future where we work in harmony with our planet, not against it, a future where the challenge of deploying solar at scale and speed has been met with a solution so transformative it redefines what's possible. The path to a fully sustainable world is still long, and challenges undoubtedly remain. But with every project like this, with every innovation like the 5B Maverick that can be deployed 10 times faster, using 70% less labor, generating more power per hectare, and leaving minimal waste, that path becomes clearer. With every dedicated mind, from the engineers in Adelaide to the teams on remote mine sites, the destination, a thriving, decarbonized world, feels more achievable than ever before. The sun, it seems, has been waiting patiently for us to catch up. And now, with solutions that are not just dreamt, but are built, shipped, unfolded, and plugged into our future, it appears we finally truly are